Yes, sir.
Shall I start, sir?
Yes.
Yes, sir. Please start. 1 minute, sir. We'll introduce you, then you can start, sir.
Okay. Hello. Good
sir.
morning to everyone present here. I welcome you all to the 10th session of the 6-day online advanced research methodology workshop conducted by the Department of Tourism and Hospitality Management in collaboration with the DST-funded Technology Enabling Centre, Mizoram University. Topic for today's session is structural equation modeling, where we'll be introduced to the concepts, its types, model building, and testing in SEM, along with a hands-on demonstration using smart PLS software. I'm Uddipan, research scholar, Department of Tourism and Hospitality Management, Mizoram University, and I'll be coordinating both the session for today. I request all the participants to kindly keep their audio and video turned off during the session to avoid any disturbances. Any queries and discussions may be taken up through the chat or by using the raise hand option. Now it is my privilege to introduce our research person for today's session, Professor R. Kasilingam. Professor R. Kasilingam currently serving as the Dean of School of Law in Pondicherry University. He also served as a head in the Department of Management Study, Pondicherry University. He has more than 30 years of combined industry and academic experience and possesses a remarkable multidisciplinary academic background with qualifications in management, finance, business law, company secretaryship, cost accountancy, computer applications, and artificial intelligence. His areas of expertise include financial management, business analytics, econometrics, and data visualization. His research specializations are commodity and capital markets, asset pricing models, corporate governance, and disclosures. He also has expertise in statistical consulting, training of data analysis, and research methodology. Professor Kasilingam is an accomplished researcher with 197 plus publications, more than 500 citations. Currently under him, there are 16 PhD scholars and more than 150 thesis evaluated.
Okay. Thank you, gentlemen. Thank you. So nice. He has given, in fact, a fantastic introduction. So whenever the people introduce, they will take some brief what I have written in the website, and they will tell only that. But the gentleman has taken effort to know my profile from different places. Okay, so very nice. Okay, so now we'll go to the subject. I'm audible, gentlemen. I'm audible, gentlemen.
Yes, sir. Yes, sir. You're audible.
Yes. So I will. My screen is visible to you?
Yes, sir.
Okay. Now?
Visible, sir.
Yes, sir.
Oh, read what it is written.
Mediation and moderation.
Very good. Thank you. So now, okay. So I will try to introduce something. The time is a little limited, but I will try to introduce what is some, what is, okay, different software used for some. And mainly, I will be covering mediation and moderation. That is what will be interesting. So first of all, okay, we need to know the regression. So I will take some time to introduce the regression, right? Okay. So now, so the purpose of regression is to find out the influence of one variable on another variable. Now, if you take here, so A is one variable, B is one variable. Right. So now we will be trying to find out the influence of A on B. So in that case, A we call it as independent variable, B we call it as dependent variable. So now let me tell very clearly what is the purpose of regression is to find out the influence of here A on B. So this we call it as a simple regression because we have only one independent variable, only one dependent variable. So now what are the things we have to see? I will tell, then I will go to the another. So now I will take some data and I will run. Okay, so that so now okay, so now I will take some data. Okay, so now I am taking SPSS software. Okay, so to tell that. Okay, so now here I have two variables. One is called income, another is called savings. So now I'm going to find out the influence of income on saving. All right. So this is a SPSS software I'm using. So this is one variable income. All right. Can you see my screen? Yes. Okay, fine. So this is my okay. So screen total income. This is total savings. Right. Very good. So now what I'm going to do is I'm going to run a regression. Okay. So regression linear. And I'm going to put the saving as my dependent variable and the income as my independent variable. Now, okay, so now what happened? So now I will be getting three tables. So three tables. So now the table. So we need to know the meaning of each and every item, then only you can say you can understand regression. But basic thing, one thing I will tell. Now my objective is to find out the influence of independent variable on dependent variable. Okay, so now my independent variable is income, my dependent variable is saving. Now look at here last coefficient table, income. Here I'm looking at this significant value. This sometimes it is otherwise called as a p-value. I'm looking at this significant value. Since the significant value is 0, 0, 0, 0, since it is less than 0.05, we say there is a influence. We say there is a influence. So now we say there is a influence, right? Okay. So like that, there are many things we can use a t-value, or you can write the equation with this. So now this one, then of course you will be interested to know R square. R square is degree of determination. What extent we determine? What extent we determine saving with the help of income. So now only 16 per 1.163, only 16% of our savings depends upon the income. So remaining is influenced by other variables. The way changes in saving, 16% of these changes in saving depending upon the income. So 16% of the changes in saving depending upon the income, that is the R square. So though R square is very less, so now we have a model fit statistics. So this is ANOVA. ANOVA table is significant value is 0.000, which is again less than 0.05, which means our model is fit. So in our regression, we have only one model fit statistics, that is the ANOVA table. So which means, what you mean by fit? So we say our model is sufficient, our model is fit, which means we are sufficiently predicting. We are sufficiently, when we say model fit, we are significantly predicting, significantly forecasting, significantly determining, whatever you can want to say, you can say. So normally, though there are many things, I have introduced only three. Okay, so the significant value, if it is less than 0.05, it is influencing. Then R square value is 6.163, 16% is depending upon this independent variable. And our here, okay, so ANOVA table is significant. So ANOVA table is significant, which means we are significantly predicting. So this is what we need to understand with the help of regression. Okay, now I will go to some of the software. Okay, so I will try to introduce if you look at this, please, you can note down the values also. You can note down these values also. For example, some of the values, significant value is 0, 0. and my beta is 0.161. My standardized beta is 0.404, right? You can note out my standardized beta is 0.404. My beta is 0.161. My R square is 0.163. Okay, so my A value is 3,281. All you can note up. A value is 3,200. So now I will be using some other software that is called the some software. Okay, that is AMO software. I'm going to use AMO software and I'm going to test. So now this is a file new. So I have so this is the drawing area. The white area is a drawing area. You have to draw whatever you want to do in this white area only. So now I have a variable for which I have a data. So that okay. So that kind of variable we call it as a observed variable. So to have observed variable, we will be using this one. So this is called observed variable. Okay, so now I used observed variable. Now to have influence, I will be using this arrow. So I'm using this arrow. One-sided arrow. Okay, so this one. Then I have I have to put the error. I've drawn. So I got one independent variable, and okay, I used this arrow. So to have a link, I have a Excel here. Okay, so now let me go to the Excel. So I have connected the data. Then okay, say okay. So I have connected the data. Then I have to assign variable to each box. So I have two variables. My independent variable is income. My dependent variable is this one. Okay, now done. So I have to name the this also. Now for which I can right click and name the variable, but here clicking name unobserved variable or circle or unobserved variable. So this is done. So now I want to have I want to show you the in the output. I want to so intercept also 3,281.033 also I have to show. In the output, I need to show standardized 0.404. Okay, that also I want to do. So I want to show R square also. So it's quite a multiple correlation. That is okay. So that is why I click. Now if I am clicking, look at this one. This is not enabled. Okay, so now clicking this, I will be using this is for collecting with the data. This is for property what you want to have in the output, and this is what analyze, calculate, estimates. Here you see not visible. Okay, so now if you click it, okay, it is asking me to say. Okay, so I will say Mizoram 1, right? Let me put Mizoram University 1. So now done. So when it is enabled, which means it is done. So now you can see here, okay. So this is 0.61, right? 3,000. This is my alpha value. All it is there. So, but irrespective of this, okay. So this is a graphical output. So in the graph itself, we have output, and but let me show the text output. So text view text. I'll go to this view text. Okay, so now you can see what you can see is right. So my total income to total savings, you can see my beta 0.161, and you can see probability value 0.000. That is significant value 0.00. My standardized beta value is 0.404. my the intercept value, that is a value is 3281. My R square value is 0.163. So now this AMO software also will give the same result. Okay, so it is not okay, showing a different results. So when you know what is the inference, how to make, how to write for regression, then that same thing you have to use it here. So significant value, same thing. Here it is p value. Then here the beta value is called estimate. Here standardized beta. Here like that. Okay, so squared multiple correlation is the R square. Okay, same thing you can see here. Now let me go to the another software, that is also another software that there also I will demonstrate. Okay, so from the beginning I will tell. So now new project. Okay, click this new project. It will come new project. So let me put Miso. Okay,
Sir, can you tell the name of the software, sir?
I will tell. Wait. So I will be asking many questions. Rather you asking me question, I will be asking many questions. What is your name, madam?
Sir, Velviri, sir.
Okay, then I will ask many questions to Elvili, please. Okay. So now this software is it is written here, Smart PLS software. That is what I am using. So now see here new project. I have clicked new project. The new project has come. Okay, so I have clicked this new project. It has come, right? Okay. So you have to carefully listen. Okay, because I'm going very fast. Okay, if you have any doubt, I will be in the course of time. I will tell. Otherwise, you can keep waiting, right? So don't keep it in the mind. Okay. So now this I'm double clicking. I'm double clicking it here. So to link the data. Okay. So I'm linking it to the data. Okay. So it is asking me database name is like that. Yes. Okay. Which name you want to give? So now this is, now you can see this is the project name. This is the data set name. I have clicked it. So it will give for both variable what is the mean, minimum value, all descriptive statistics automatically it will come. So now I'll go to this one. So now when I clicked, okay, so what happens, I'm getting this window. So already I used many, that is why, let me close it. Okay. So now I have here two things. This is to open data set. So this is for, okay, path. This is the path diagram I have here, path place. Now I have only two variable. Okay, so I'm taking this income and I'm putting here. So then I am taking this one and putting it here. Okay, so now drawn. Okay, so now what I'm going to do is, so I want to put it a little, I can change anywhere this one. Then let me put it right. So just click it and so now this is on this side. So I want to put it on the other side. So align to the right, align indicator, that is called indicators, align to the right. So it will go here. Now I have to connect the line, this connect. Okay, so I'm connecting with the line. I'm connecting with the line. So done. So this is connect. After connecting, I have to, okay, so this select so that it will go. So now the latent variable it is okay. So let me rename the variable. So that is let me rename that. Let me call it as income. Okay. So this variable, let me call it as right click. Okay, name. So savings, total monthly savings. So monthly income, monthly savings. So now I have two. So I have drawn here, it is very easy, just track it and put it. Just left hand side, we have items, so track it with the item and put it. If you want to change it, click it and track, you can track anywhere. Okay, so that is possible. So here only few things, this is for connecting, this is for connecting. So connect and I have connected. Okay, then. Okay, so drawing over. Now here the calculate estimates. This is the calculate estimates. So PLS algorithm. So if you click that calculate estimate, the calculate estimates appear only in this path diagram with this window. So there are two windows now. Okay, so data window and the path diagram window. The path diagram window, okay, this menus will appear, different menu and different this. So now done. Okay, so now start calculations. Now, okay, the my beta value is 0.404. Now, well, madam, what is this 404, madam? What is this 404?
R2.
R2.
No, no, sir. This is the beta value, sir.
Okay. Okay. So no, it is not beta value. Or if you, I think you have not written the beta value in your notebook. Beta value is already I have told you 0.161. That is a B value. Then my A value, that is the intercept value, or alpha value is 3281.033. That I have told you. Okay, my R square value is 0.163. So that and all I have already told you. One more thing I have told you is my standardized beta is 0.404. So that you have not noted down. That is why the problem. Okay, so now already I have shown my SPSS also. Let me show. Okay, so SPSS also let me show. My standardized beta value is 0.404. My AMOS software also I will go and show you. My standardized beta is 0.404. So now if we go here in the smart PLS software, this will not give unstandardized beta. Whatever beta value, it is a beta, it always gives us the standardized beta value only. So now you can see the standardized beta value is 0.404. Okay, now you may not have, okay, the significant value or p value. To get to the p value, okay, so let me go to, now we have three okay window. One is a PLS algorithm window, another is the path window, another is a data set window. Now, okay, I have to go to the calculate estimates, but I have already told you only in the path window I can see that calculate will appear only in the path window. So now let me go here and let us say bootstrapping. Okay, then calculate estimates. Now I will get the beta value. All right, okay. Now you can see the beta value. Beta PRP value is 0.00 as we have seen. Okay, so my original this one. So it will range this way. So that okay, so my p value is, so when you run the bootstrapping, then you will get the significant value or p value, right? Okay. So now okay, now if you want to see the R square value, if we click this, okay, if you click the this is this one. Now if you click the this, okay, PLS algorithm, then you'll get the R square. So here you will get only p value. In the PLS algorithm, you will get the R square value. So R square value you can see 0.163, adjusted R square is 0.162. So that we have already noted down. So now what I'm trying to tell again, whether it is smart PLS software or the AMOS software or the SPSS software or R, whatever the software you use, you will get the same output. But here we can find out this gives only the standardized beta, not unstandardized beta. So, but to write the equation, you require only the unstandardized beta. So that is why people who are using smart PLS, they will not be writing the equation. So how to write the equation? Now I will tell you how to write the equation. Now, so this is my A value, 3281.033 is my A value. This is my beta value. So Y or estimated Y, E of Y or Y hat equal to 3281.033 plus 0.161 into income. So estimated savings is equal to 3281, that is the A value, 3281.033, that is the A value. Then plus B value or beta value is 0.161. So by using this one, I am writing into income. So that is the estimated savings. So now, okay, so this is the way you have to write it. So the AMO software will give many things, many things, right? Okay. So okay, so with this we'll stop regression. So any doubt on see, if you ask more and more on regression, I can tell, but time will be consumed. So based on what I have discussed, if you have any question, you can ask me now. Yes. Any question?
Sir, which software do you think is best and best suitable for writing papers on regression, sir? Smart PLS or MOS?
I have told you all are giving same an answer. How come one can be better than another one?
Sir, but sometimes when we use
No more further question. Right? With
Yes,
respect to regression, all software will give the same answer.
Yes, sir.
Okay.
Thank you, sir. Yes.
Okay. Now I will come later. One by one, right? Okay. So now what we have discussed, now only you have to ask, right? Okay. So with respect to regression, all will give same answer. It cannot give different answer at all. If it is giving, that is a software is useless software. Okay, fine. Okay, now that is over. Now let me go to the other scenario. So this scenario is common. This is everybody can understand. So now let me go to the another scenario. What is the another scenario? But you need to know all inference is like a regression. That you need to know. Right? Whatever we have used, same thing only you have to use. Okay, I will demonstrate more and more. Okay, now I will go to the another scenario. What is the another scenario? See, for example, I have another scenario now. So this we have discussed, simple regression we have discussed. So now this also, what is this one? Now look at this one. Look at this one. Now here there are many independent variables. A, B, C, D, E, all 5 are independent variables. One F is a dependent variable. Oh, F is a. Hello? சொல்லுங்க சார். நான் வந்து 12 மணிக்கு பின்னாடி வரேன் சார், 1 மணி போல ஒரு ஒர்க்ஷாப் ஓடிக்கிட்டு இருக்கு சார். அதை முடிச்சோன்னா இங்கே வரேன். ஓகே ஓகே, தேங்க்யூ சார், தேங்க்யூ. Okay, now, now I'll take same thing. I'll take this corporate image, that data set itself I will take. If I have that data set. Already open. Okay. So now what I will do is, so in this data, let me run first regression with only one variable for this data set. So now attitude is my this one, then so my customer, okay, loyalty is my dependent variable. Okay, corporate image is my independent variable. So I'm running this, I'm taking only one variable, then I will get, okay, see, this is the output I will get. Okay. So I'm getting like this. So when I take only one variable, corporate image is my independent, behavioral intention, that is loyalty, is my dependent. Now what I'm doing is I'm going to run a multiple regression. So linear. So corporate image. Okay, so perceived value. Okay. Customer satisfaction. So I have taken one dependent variable, that is a loyalty, whereas I have taken three independent variable: corporate image, perceived value, customer satisfaction. So now if I click that, okay, so so now I can understand, okay, look at my dependent variable is loyalty, my independent variables are three. So we have to look at the significant value. So corporate image significant value is 000, which is less than 0.05, which means corporate image is influencing a loyalty. And perceived value also 0.004, which means the perceived value is influencing. Then customer satisfaction 0.000, which means this is influence. Okay, fine. Now I know all three variables are influencing. All three variables are influencing. Okay. Okay. Now, okay. Now what happens? I'm having three independent variables. Now what I'm going to do is I'm going to run the correlation with for three independent variables. I'm going to run. I know that three independent variables are influencing my dependent variable. Fine. Pakka. Now I'm going to use the correlation. I'm going to use correlation. Why I'm using correlation? Right, among the independent variable, now corporate image, all right, then perceived value and the customer satisfaction. These are all my independent variable. I'm using correlation. So how I am using? Analyze, correlate. Analyze, correlate. I'm using this one. Now look at my results. Okay, so how I have done? Let me tell again. So now analyze, correlate. Okay, so if bivariate, analyze, correlate, bivariate. If we go there, this will come. Then you have to put whatever variable for which you want to find out correlation. You say you will get the result. Now look at the significant value or otherwise R value. Significant value. Let us look at the significant value. Corporate image relationship with the perceived value. Corporate image perceived value. Right. So this is 0.00, which means corporate image and perceived value are related. Now corporate image with the customer satisfaction, the significant value is 0.000, which means that is also related. So now look at the perceived value and customer satisfaction related, which means all in three independent variables are related to all significant values are less than 0.05, which means all independent variables are related together, related with each other. Okay, so that is what. Now look at our assumptions of, okay, so now this is what, okay. This we have seen. So I have written the equation with the three variable. Now I am showing the relationship here. So I am showing the relationship. All corporate image related with the other two, perceived value related with the other two, customer satisfaction related with this. Fine. Now the OLS assumption, that is ordinary least square or regression, it is having 7 assumptions. Assumption number 6: no independent variable is a perfect linear function of other explanatory variable. Explanatory variable means independent variable. So this assumption says no independent variable is related with another independent variable. So yeah, okay. So otherwise, all independent variables should not be related. If they are related, that is called multicollinearity. So then, if there is a multicollinearity, you will get very high R square. Very high R square. So now let me run one more. Okay, so this issue are supposed to simple. Otherwise, let me tell. Whenever we say independent variable, it is independent. independent. It is not related with anything. It is not influenced by anything. That is why it is called independent. That we need to know. So what is independent variable? It is independent. It is not influenced by anybody. It is not having any related with anything. Okay, so now I have shown the okay, so I have shown the correlation. I have shown the correlation. In the regression itself, we can find out whether there is a no. Okay, now I have this one. Now let us analyze regression, linear. So here, if you go to statistics, if you click this collinearity statistics, okay, continue, and if you say okay, then you will get to the collinearity statistics here. Right. So look at these two are collinearity statistics. These two are collinearity statistics. So this tolerance value should be greater than 0.5. Right. So this when it is 0.5, then it should be less than 2. Okay. 1 by tolerance is the VIF. Okay. Sometimes people say 3, but the tolerance is very, very less. So now here, of course, our R square is a little less. I will show the another case. Okay, tolerance. Now let me go to the another case. So now I have 6 data, I have gold. Okay, look at I'm going to run regression. So now linear, multiple regression. So all are independent variable, then gold price is my dependent variable, So now first let me run, then I will show. Now if you run here, my R square value is 0.99. Right, my R square value is 0.99. Okay, which is okay. R square value is 0.99. People might say that, hey, very high R square. So whenever you have this kind of R square, which means there is some problem. So very high R square is not a good fit actually. Okay, so now I say, now let us see here regression. Let me run the multicollinearity. So statistics, collinearity. Okay, you can see here. Okay, the VA value is 68, 23. Okay, my tolerance 0.015, very less tolerance, very high VAF. So this is very, very dangerous. That is why our R square is one independent variable, predict another independent variable, then that independent variable will be influenced. Like that it is going on. So now this is a very dangerous sign. Okay, you are not supposed to use. Okay, sir. Now what to do, sir? Only for us, right? Now, which means one independent variable is influencing another independent variable, right? So which means, okay, but we have only one dependent variable, fine, pakka, loyalty. But one independent variable influencing another independent variable. So that variable, we have to take it as a mediating variable. That variable, we call it as a mediating variable. So this influence that again influence this. Now we know that independent variable is influenced, but what happens? One another variable is influencing the another independent. So now what happens? Okay, sometimes okay, your independent variable may not be related directly with your dependent variable, but if you put one another variable in the middle, so then it will influence. So there are many purpose for which we go for a mediation, but you please understand this way. So this variable is related with another variable. Okay, that you are not interested in. Okay, so these two, if we treat that also independent variable, that is a problem. So what you are seeing is you are putting as a mediator, which means one independent variable influencing that variable, right? Again, that variable influencing the dependent variable. So that is why we call it as a mediator. Now I'll show the diagram. What is so now it is like this now. Okay, so loyalty I'm keeping is dependent. So CA I want to keep it as independent. This is have a relation with the where. So let me have like this. Let me have a like this with this, which means the CA is influencing val is influencing this one. So CA is also independent to loyalty. So now if you say there, as far as loyalty is concerned, this val and CA is independent variables. Okay, independent variables. Fine. Okay. So now this we call it as a mediator. Okay. Now, okay, what to do? What to do this one? Then I will show one by one. I will show one by one. So first I will use I will use AMO software. Then I will demonstrate how it can be done through regression. Then I will tell how it can be done through, okay, so smart PLS. So now I will go for, okay, so I want to keep one variable as a mediator now. So the question of mediation is coming. Now you know why the mediation is coming in. So now let me, okay, so this we have used, okay. Why? New. Okay, so I'm going to draw how I am going to draw this one. So here, okay, here, okay, fine. So if you want to change the place, okay, so use this lorry to move from one place to another place. So let me use, let me keep a little lorry. So let me use a little here, fine. So now place properly. Let me use this single arrow. Okay, so here to here. Okay, so here to here. Fine. So whenever go near to that object, the color will change, which means you are touched. So this is a brush to make arrangement perfect. Okay, fine. So brush I'm using to properly align my diagram. So drawing over, okay, now not drawing it over. So wherever there is a dependent variable, whenever arrow end, that is called a dependent variable or endogenous variable. Dependent variable otherwise called endogenous variable. Okay, so otherwise, okay, independent variable called as independent variable or explanatory variable or exogenous variable. So I have given the error for each dependent variable. Where is this? Okay, fine. That, okay, connect the data, connect the data. Data connected. Okay, so now align the, okay, align the with e variable, right? So this is CI, this is my CI. Okay, so this is my, okay, I'll put val and I'll put loyalty. All right. So this is little big. So what I will do is, okay, view interface properties, miscellaneous. So display display variable name unchecked, which means it will not display the variable name. Okay. So then, so these two have to name error. So plugins name unobserved variable or circle or unobserved variable. All done. All done. Okay. Analyze property. What you want? Okay. I want this standardized. I want this squared residuals. These are squared multiple correlation, right? Squared multiple correlation. This also I will come. This also I will come. Direct, indirect. Whatever you want, you have to click it. Okay, done. Okay, so now this calculate estimates. These three are important. This is for connection. This is for analyze property. This is for calculate estimates. So now M2. So now done. Okay, so now click this one. The result is ready here. The result is ready here. So now it is a text uprooted. Now, for example, if you want to select one by one, you press this one hand. If you want to select all, select all this all fingers. So see here, now it is black. Now I have selected color is changed. You put okay. So you put Control C. Then go to any Word document. I have a Word document. Then sir, department தான் இருக்கிறேன் சார். நான் 12 மணி வரைக்கும் நான் ஒரு ஒர்க் ஷாப் நடத்திக்கிட்டு இருக்கேன் மிசோரம்க்கு. நான் வேணா யாரையாவது அனுப்பிச்சு விடுறேன்னு கொடுத்து விடுங்க, அல்லது நீங்களே வந்துட்டீங்கன்னா பெட்டர். 12 மணிக்கு மேல பிரச்சனை இல்லை, வந்துடுவேன். Okay, thank you. So now they pasted Control B. I put it is pasted. So the select by using the hand Control B C and Control B. Okay, done. Now okay, okay. So val CI this one you need to understand CI influence val this right. Okay. So now I will show the okay, so now if you want to deselect, they close the hand, it will go. So now this output, okay, so estimates. So now this 0.826, 0.229, 0.509. So these are all my standardized estimates. So these are all my R square, right? You can note down these values, right? If necessary. Okay, so let me note down these values. So CI to val. CI to val is 0.826. So it is P is 0.00, significantly influencing. Okay, so val to loyal is okay 0.229. Then CI to loyal, so it is 0.509. Okay, so my standardized beta is 0.665, 0.291. 0.522, right? These are all my standardized values. These are all my unstandardized value. Now, one thing is it is influencing, right? My R square is VAL R square is 0.442, and loyalty R square is 0.560. Okay, fine. Now you know we have to write it is influencing R square is this much all. Now, okay, now. Okay, so now this is whatever I have written 826, 0.229, 0.509, Okay, all it is here, whatever I have told you. Okay, now same thing, whatever I've told you, another basin. Now what I'm going to tell is, here, whenever we look at the mediation, we will say two things. One is called a direct effect and indirect effect. CI to loyalty is called a direct effect. So CI to val and val to loyal, that is called an indirect effect. So how to find out direct effect? CI to loyal. Okay. So what is the value? CI to loyal. Okay, the value is 0.509. Here it is 2 digit. That is why it says 0.51. So direct effect is CI to loyal. See here, CI to loyal, the value is 0.509. So my direct effect is 0.509. So now let us find out the indirect effect. Indirect effect is CI to val, val to this one. So now let us write indirect, right? CI to val to loyal. CI to val, CI to val 0.826. So val to loyal, it is 0.229. So if you multiply 0.826 into 0.229, it gives 0.189. My direct effect is 0.509. My indirect effect is 0.189. So my total effect is, if you add both, if you add indirect effect, direct effect and indirect effect, so you'll get 0.509 plus 0.189. So 9 மிச்சம் 1 9 5 1 6. So 698, 0.698. So this is my total effect. So now let me tell. So this is called a direct effect. This into this, we call it as a indirect effect. So 0.826 plus 0.229. If you multiply, you will get the indirect effect. If you add both, you will get the total effect. Okay. So now is it okay? Direct effect, indirect effect. Hello? Hello?
Yes, sir. It
Yes,
is
sir.
okay.
Okay, fine. Okay, fine. Now what I will do is, now I will show in the, this we have calculated. In this we have calculated. Now we'll go to the output itself, because we have clicked the, you have clicked the direct effect, indirect effect, total, that also we have clicked it. So here it will come. Now see here, total effect, CI to loyalty, total effect is 0.698. That is what we have calculated. CI to loyalty 0.698. So now if you take the direct effect, CI to loyal 0.509. My indirect effect, if you have noted down, you can understand. My indirect effect, CI to loyal is 0.189. So whatever we have calculated, whatever we have told, the output, say, software also giving the same output. Okay, fine. Now, now I'm going to, what I'm going to do is, I'm going to perform this with the help of the regression itself. So now we'll try to understand how it is. So now please see here, I will ask one question, probably that Velvili madam. Now see here, direct, see, we need to understand clearly. Let me tell you very clearly. The direct effect of CI on loyalty is 0.51. My indirect effect means what? CI to loyal. Indirectly, CI is affecting loyal through val. That is called indirect. CI to val, my indirect effect is 0.189. So now my total effect of CI to loyal is 0.189, not 0.698. The total effect is 0.698. Correct? Correct. I hope you might have understood. Now, now I'm going to ask one question. Now I'm going to run a regression. I'm going to show all. Now the Velvili madam, by looking at this diagram, how many regressions are involved here in this diagram? How many regressions are involved in this diagram?
3.
3, sir.
3 regression, right? Anybody else? Anybody else?
Sir, is it 5, sir?
5. Anybody else? No one? Hello? Okay. So now it is not 3 regression, it is not 5 regression, it is only 2 regression. Only 2 regression. Now I am going to tell. Okay, now CI2 val 1 regression. CI is independent variable, val is a dependent variable. Okay, now what is the value? 0.83, now exactly 0.826. Okay, CI2 val 0.826. Okay, so I am going to show 0.826 by running one regression. CI is independent variable, val is a dependent variable. Okay. So analyze regression, linear. Okay. So I put val is a dependent variable. Okay. Corporately CI as a independent variable. Right. So what I should get? I should get 0.826. Okay. So now let us go here. Or let us go here. Okay. So you can see, okay, the tolerance, whatever I click, 0.826. Are you noticing 0.826? Yes or no?
Yes, sir.
Yeah. So now one regression I have done. Okay. Now I have to run another regression. What is another regression is? Okay. Now let me show the table. All right. Okay. It is there. Everything it is there. Okay. I'll run. Okay. Sorry. First I will show how I am going to run. Okay. Now this we have seen. Okay. Now loyalty is my dependent variable. There are 2 independent variables. 2 arrows are coming in. Val is 1 arrow and CI is 1 arrow, which means this is a multiple regression. This is a multiple regression. Now I am going to run a regression. Okay, how? VI and val and CI are 2 independent variables. Loyalty is my dependent variable. So now what is the output I should get? CI to loyal, it is CI to loyal, it is 0.509, 0.509. Then val to loyal 0.229, 229, right? Okay, so this is the 0.229. Okay, so that I should get. That I should get. So now let me run. Analyze regression linear. Okay, so not the perceived value. Okay, so perceived value is my independent variable. See, my loyalty is my dependent variable. So now let us see here. See here, right? This loyalty is my dependent variable. CI, right? You can see 0.509. 0.509. This is 0.229. Right? 0.229. Okay, you can see my R square also. My R square is 0.560. Already we have noted on 0.560. What is my CI2 earlier I have run? Okay, I should get 0.442. 0.4, my R square is 0.442. So whatever I got in Amos, I have got this thing also. All right, very good. So we have seen what is how to calculate indirect effect, all these things. Okay, now. Okay, so I have demonstrated by using regression also we can get the same information you are getting. But the problem is, what is the problem here? Okay, we are running this with one simple one stroke. Both regression we are running. There we are running regression 2 times. Regression 2 times. Now here we have taken only 3 variables. So if you take more and more variables, then what will happen? Okay, but here any number of variables you can put it in one stroke and you can calculate. You can calculate, you can do. Okay, so but there you have to run many regression to demonstrate that. Okay, so here we are running regression simultaneously. We are running regression simultaneously. So the equations are arranged in a structural form. So that is why we call it as a structural equation. Otherwise, we call it as a path diagram. This is called a path diagram. Different paths are there. So this we call it path analysis, path diagram, structural equation, many equations, simple. Many equations we are running in one stroke. That is the idea. That is the idea. Okay, but all are regression only. But later many more things are coming. I'm building it. Right, slowly I'm building it. So many regression we are running. Fine. Right. Okay. Fine. Now I will ask one simple question. If you are given the answer, then I think you have understood the matter. Now suppose, right now, okay, for your sake of itself. Now, okay, first what I have done, I have taken CI is independent, val is a dependent. Then I got this value, CI val 826. Then what I have done, loyalty is my dependent. These two are independent. Then I got this 229 and 0.506, 509, right? Okay, fine. Suppose if I run one regression by taking CI as independent, loyalty is a dependent. What is the beta value I get? Well, will you, madam? Hello, madam. Will you, madam?
Sir.
Yeah, tell me answer.
Yes, sir. Yes, sir. It is the combined total, sir.
Okay. So now it will give the
0.69,
total
sir.
effect, because so what is total effect? That is the influence of loyalty directly and indirectly, right? Totally its influence, CA influence on loyalty is 0.698. Okay, now I will run and I will show. CI and loyalty. Okay, you can see here 0.698. 0.698. Correct? Correct? Is it okay, madam? Okay.
Yes, sir. Yes, sir.
So fine.
Yes, sir.
Okay. So now what is mediator? Okay. So now, okay, one more thing I have to tell. Okay. So now, okay. So this is what I have demonstrated. Okay, now I will take a smart PLS also. Okay. So now what I'm going to do is, okay, same thing I'm going to draw CI here. Okay, then val here, right? Then val here. So now I'm going there. This is right hand side, aligned to the right. This okay, this let it be, no problem. Okay, fine. Okay, now I'm going to draw this connect. Okay, so this one and okay, so now of course this one. Okay, done. So now let me change the name. Rename. So that is called CI. Okay. So this we call it as val. This we call it as loy. Okay. So now this is over right there. So now calculate estimates. PLS algorithm. Okay. Now here itself we can okay, we'll have the significant value also. Bootstrapping. To get the significant value, you have to run. Okay, so now here, okay, I already told you this will show only the standardized. Okay, that is why I already noted down the standardized. Okay. So CI to val, my standardized is 0.665. So you can see CI to val, my standardized is 0.665. I already noted down. So CA VA val to loyal 0.291291. Then that is a 0.522. All are significant. All are significant. So here easily you can see total effect, indirect effect. You can see here. Okay. So now if you want to see indirect effect, okay. Total indirect effect. So already we know it is indirect effect. Okay. So how much? Okay. Then total effect. But by using the standardized, multiply only, same multiply only, but the standardized value you should multiply, you should get it. Then we have R square value, right? Okay. Okay, something 0.442, 0.560. So if you want to have the R square value, you have to go to the path diagram. Okay. Not path diagram, algorithm, PLS algorithm. PSLS algorithm, we have R square. So click R square value. Already we have noted down 0.560, 0.560, 0.442. Okay, so same thing. Okay, so but it is quite easy, So the one madam has asked me what software you can use. So I suggest this PLS okay to many people. Okay, but We use extensively AMOS only, but many people they use this one because it is very simple to operate. Number one. Now, number two, even if you have a small sample size, this will be suitable. So if you have a small sample size in AMOS, it will not give you even a result. Whether the result is good or bad, that is a different story. Okay, you will not get the result at all. Then when your data is not normal, then you can use PLS. So let's see the many advantage. Number one advantage, very easy to use. Now even small samples you can use. Even the data is not normal, you can use. Even if your diagram is very complex, then you can use. it. Then your purpose is only prediction, not for model building. Then you can use this software. That is a smart PLS. Very easy to use. You will get the result even for a very small sample size also. Okay, you need not draw different diagram for measurement model and for path model. Same diagram can be used here itself. Measurement reliability, discriminability, all model fit, all you can get here itself. There for measurement model you need to draw different model. For path diagram you need to draw different model in AMOS, right? But whenever you are going for a model between, so that is a covariance based, this is a variance based or regression based. So that is a covariance based. So that is for model building. Okay, whether you are building any theory or you are testing some theory, something like that, that you have to use. This is only for whenever your interest is prediction. So here our most important model fit is R square. Okay, so now, okay, fine. Now this is the, okay, I have demonstrated with this one. Okay. Now, by looking at this, what you understand? Earlier, we know that, okay, all three independent variables are related, right? All three independent variables are related. So which means one independent variable influences other independent variable, right? So no two separate independent variable not possible, right? Very good. Now, okay, by looking at this, somebody, can you tell me what you understand by looking at this diagram? Quick, come on. Yes. Well, madam.
And there are two mediators,
Good.
perceived value and customer satisfaction.
Very good.
There is
Okay.
there are three
Okay. Now,
predictors.
wait. Now, let me tell again. Whatever you are told is first, right? So, corporate image is the independent variable. Loyalty is my dependent variable. Now, perceived value and the customer satisfactions are two mediators, M1, M2. Yeah. What do you understand further? What do you understand further?
But the path through perceived value the path through customer satisfaction is not direct. It can be through perceived value also. So together, perceived value and customer satisfaction can act as mediator. So in one single path, there can be two mediators.
So now in AMOS, any number of mediators can be included, or anything, anything we can be, any number of mediators can be included. Oh, fine. But in regression, okay, so it is not possible. You can have only independent, only one dependent. All right. So many independent, one dependent. Now, by looking at this diagram, okay, so can you tell me how many regression I have to run?
Three, sir.
Oh, madam.
6 regressions, sir. 6.
No.
6 regression. Very good. Super, madam. Yeah. Now, tell me one by one.
Sir, corporate image to perceived value, 1 regression.
Yes, very good. First, you have to go like this. Perceived value dependent. only one arrow is coming.
Yes,
Only
yes.
one arrow is coming. So by taking perceived value dependent and the corporate image independent, you will get one regression.
One
Okay.
regression.
Next.
And corporate image to customer satisfaction, one regression.
Wrong answer.
Wrong. Okay.
Now, okay. Now the symbol. Look this way. Okay, look this way. See, this we have taken. Now let us come to this. Take this as a dependent variable. Okay, how many independent? 2 arrows are coming, which means perceived value were independent and corporate image independent. So 2 independent variable, 1 dependent variable, customer satisfaction. Okay, so 1 multiple regression here. So 1 dependent, 2 independent. Look at the arrows. Perceived value 1 independent, customer image 1 independent. Next, when you come to the loyalty dependent, 3 independent. Customer satisfaction 1 independent, perceived value 1 independent, customer image 1 independent. Okay. So now if I run, this is my output. This is my output, right? So when I run by using Amos, this is my output. Okay, fine. This is my output. Fine. Now this is my output. Now, okay, I've already told you this I can get by running 3 regression. 3 regressions results are here. Now, first regression I have told you, CI independent, val is dependent, right? That is customer value. So look at what is the beta 0.826. Now I have taken. Perceived value is my dependent. Corporate image is independent. My beta is 0.826. That is what we have noted down. All right. So now Amos is giving 1 result. This is the result you will get. First table you will get from Amos. Right. Now I'm getting those results by running 3 regressions. So first I have told you, if you should have written down perceived value 1 dependent, this 1 independent. Next, when it comes to customer satisfaction, these 2 are independent. When it comes to loyalty, these 3 are independent. 3 lines are coming. So now see here. So CI to val 826, CI to val, customer image to val 0.826. Fine. Now let me go to the another one where, sir, Vanga. The workshop, sir, Mizoram. Sir. நிறைய கைது போடணுமா சார்? அது கூட நான் வந்து போட்டுக்கிறேன். இதை மட்டும் வாங்கிக்கிறேன் உங்களுக்கு தேவையான ஃபில்அப் பண்ணணுமா? நான் ஃபில்அப் பண்ணி கொண்டாடுறேன். நான் ஒரு 10 நிமிஷம் தான் இருக்கு. வந்ததுல பாக்குமா பச்சையா? சும்மா ஒரு இடத்துல போட்டு விட வேண்டியது. Thank you, sir. So now let us look at the second one where customer satisfaction dependent, 2 independent, 0.532, customer satisfaction 0.532. So this is the 0.343. Look at perceived value independent, customer satisfaction dependent. Perceived value to value is where is value? Perceived value independent. Okay, to customer satisfaction, value to satisfaction, it is 0.343. Okay, 0.343. Next is by taking customer loyalty dependent, 3 independent customer image perceived point. You can see all 0.261, 0.261, 0.467, all the 3. Clue of green, sir. Clue. Yes, sir.
Yes.
Okay.
Okay.
Yeah. So now we can get all, okay, so one stroke, that is one. Now here, one thing you need to understand very, very clearly. So how to calculate the indirect effect? Now, indirect effect for corporate image, it is having 3 indirect effect. One is, okay, now look at the CI2 val. CI2 val, okay, so one indirect effect is CI2 val to loyalty. So now see here, corporate image to loyalty, it is having 3 indirect effect. Wow. So from val to customer loyalty 1, then customer image, customer satisfaction to loyalty 2, then corporate image to perceived value to customer satisfaction, and this one. So there are 3 indirect effects. So one is CI to val to loyalty. I'm multiplying 0.826. That value is already we have noted down now. That value I'm multiplying and I'm getting one indirect effect is 0.0569. Another indirect effect, CI to SAT to loyal. So multiply this one 0.248. Third is CI to val to SAT to loyal 0.826, 0.346, and based on that value, you can see here itself, multiply this one. So 3 indirect effect, you can see 3 indirect effect, 0.0569, 0.2484, 0.1. So if you will get 3 indirect effects, so there you'll be getting 3. Okay, so if you add all together, that will give a total indirect effect. So this is other things easy. So now this is, you can see direct effect is 0.261. Okay, by taking that. Okay, how? See here, loyalty, corporate image 0.261 direct effect. My total effect is okay. So how will I get? When you take only that as independent variable, dependent variable loyalty, I'm getting total effect. You can see 0.698, 0.698. So here also you can see. So this is direct and total, right? We can see here, right? Okay. So if you take only corporate image and loyalty, you will get the total effect. Total effect is this one. Now we have 3 indirect effect. If you add all the 3, you will get a total indirect effect. So that you need to know when you take many things. But okay, so to avoid all these things, why you want to run with mini regression? Why do you want to find out 3 indirect effect, adding all and finding out? But when you use almost directly, you can see here all total effects. You can see I have calculated all total effects. CI to loyalty already I have told you 0.698. It is there already 0.698. So for example, it's okay. CI to loyalty. How I'm getting total effect 0.698. 0.698. So like that, all I have calculated. But okay, it will give each one table. CI to val only one. So only one CI to val 0.826. Whereas CI to SAT, okay, there are 2 CI to val to this one. Okay, you have to put this one, that is multiplied. So it is giving. So total effect calculated. This is a direct effect only. This is indirect only. This is the estimate we have seen, right? This here we have seen, no, this estimate. I put it here and I put it here. Okay, by using this one, I estimated three indirect effects. We have three values. Okay, then total effect, all these values calculated and put it. So only thing is you need to know there are three indirect effects. Okay. Okay. Now one more thing. Let me tell you. In Amos, the for indirect effect, significant value will not come directly. For indirect effect, significant value will not come. Okay, but we need to know whether the indirect effect is significant. Direct effect we can see. Okay, because for each one the p values are given. But for indirect effect, p values will not be there. So to get to the p values, okay, so from here itself I will tell. Here itself I will tell. Instead of I have this 4 also. I have this 4 also. Okay, now in the analyze. So this clicked. Okay, so now I hope not this one. This I will run. Let me see whether it is running. Yeah, it is running. Okay. So it is there. Now, for example, if I want to go to the, so here, okay, here the estimates. Here metrics. Oh, sorry. What and analyze property. Sorry. In the analyze property, here bootstrapping. So these two I should have clicked. Perform bootstrapping with the 2000. Then bias this I should have done. Right? This normally it will not be there. I have already done. That is why it is there. Okay. So now if I run here, estimates, metrics, indirect effect, then this will come. Bootstrap confidence, bias, and to type. So now this is giving the indirect effect value, right? But I want to have significant value. If you give the significant value, we'll get the significant value. Okay, so upper bound, lower bound, if you want to see, you can see here. Because one software will give upper bound only. That is okay. So which software will give upper bound? See, for example, if you take process macro, it will give the, for example, I will show. Okay, see here, one more thing I will tell, okay, that process macro, it will not give significant value. So some software will not give the significant value, then you look at the T value. When the T value is more than 1.96, which means there is a influence. Significant value less than 0.05, there is a significant. Otherwise, T value 1.9 more than 1.96, there is a influence. Now, looking at the this is a lower bound, upper bound. So boot LLCI is a lower bound. This is the upper bound. When both are plus, which means there is an influence, right? That way also people can see. Right? Okay. So now we have seen. Okay, so by taking 4, what to do like that. Okay, so now we have taken 4 and we have demonstrated all. Okay, so how to calculate indirect effect multiply only. Okay, so only thing is for CI to this one, there are 3 indirect effects. You have to add all 3. First, indirect effect multiply this into this like that. Then find out 3 and add all the 3. You will get the total. You will get the other indirect effects are only 2 lines are there. This into this. Okay, fine. So now this is with respect to the okay. So now if you take the smart wheelers also, okay. So we have to take four. We have to take four. But only thing is it will be the standardized, right? Direct indirect effect based on standardized. Here we can use standardized as well as unstandardized because it is giving both. Amos is giving both. So we can use by using standardized. Regression also giving both standardized and unstandardized. Okay, fine. Now, okay, so okay. Now, okay, in the model mediation, we have one more thing to say. Now we have seen whether it is directly direct effect, indirect effect, all these things. Now I'm going to tell there are three types of mediation. One is called partial mediation, another is called full mediation, another is called no mediation. There are three mediations. Now, okay, now I will ask somebody. Okay. So where will you, madam? Where will you, madam?
Yes, sir. Yes, sir.
By looking at these two, what you understand, madam? Anybody? Anybody?
So the turnover intention is directly related to the job stress.
Anybody else?
Job stress influences turnover.
Okay, very good. That's all. Simple. Now, job stress is my independent variable and the turnover intention is my dependent variable. Right. Otherwise, here also you can see job stress. Look at the arrow. Job stress, turnover intention. Right. So my beta, this probability value or significant value is 0.043, which is less than 0.05, which means it is influencing. My beta value is 0.085. Okay. So where will madam? Where is the problem, madam? This is the very basic. First, I taught only. I've taken so much time to explain regression, same regression, only one variable. Okay. Now what you understand? Okay. First, then I will tell. Madam, tell. Where will you, madam, tell? What you understand, madam?
1 minute. For the anger, sir, which part you want me to tell, sir?
Not which part. Whatever you know, tell.
Job,
If this is shown to you, what you will understand? What you will tell?
sir, job stress influences turnover. Anger does not influence turnover. Is it like that? No.
I do not know how you are telling, what you are saying, all. Anybody else?
Sir, if we take anger as a dependent variable, then it is directly influenced by job stress. And again, in turnover intention is
No. First, let us tell one by one. Okay. Now, first from here, it is understand. Okay, job stress my independent variable, turnover intention is my dependent variable, anger is my mediating variable. that understanding you need to have. That is first one. Okay, fine. Now leave it. Now let us come to the table number 2. So we have to look at the p-value. First, job stress, independent variable, anger, dependent variable. So here p-value is 0.000, which means job stress influencing anger. Now here, okay, next is job stress to turnover intention. So this is 0.0304, which is greater than 0.05, which means job stress is not influencing turnover intention. Next, anchor is 0.003, which means anchor is influencing turnover intention. Madam, well, madam, are you understanding or not, madam? Hello?
Yes, sir.
Hello?
Yes, sir.
So
Hello?
what is the problem? You have given
Yes, sir.
exactly wrong answer you have given.
Yes, sir. Understood, sir.
No, madam?
Yes, sir.
Tell again, madam. Tell again. Tell again what I have told you.
Job stress influences anger, and job stress does not influence turnover intention because the p-value is 0.304, which is greater than 0.005.
Not
And anger
0.005. No, not 0.005. 0.05. 5%.
0.05. Okay, 0.05.
Hmm.
And anger influences turnover intention.
Okay, fine. Now, so now, for example, now look at, based on this, I can understand job stress is not influencing turnover intention, which means direct effect, no influence. So now job stress influence anger, anger influence turnover intention, which means indirect effect, there is a influence, both this and this. So which means there is no direct effect, but indirect effect is there, which means this kind of mediation, we call it as a full mediation. This kind of mediation. So anger is a full mediator. Only job stress is not having relation, which means only through anger you can go. Job stress directly it is not having intention. So only through anger job stress can act. So mediator. Why mediator? It brings relationship. So there is a full mediation. Now quickly, somebody quickly. Somebody quickly.
Sir,
Somebody quickly.
turnover intention is
Job-
influenced by job autonomy.
Job
Job
autonomy
autonomy
influencing, okay,
turnover.
turnover intention, right? Job autonomy is influencing, right? Next.
So turnover intention is influenced by job autonomy
Now, why you are
directly
going in the reverse way?
as
Why
well.
you are touching, sir? Why you are telling the reverse way? Go direct, sir. Job autonomy is influencing turnover
Job
intention.
satisfaction.
Job autonomy is influencing job satisfaction. Like that, you tell, sir.
So the job autonomy is influencing job satisfaction. Also, job autonomy is influencing turnover intention, and job satisfaction is influencing turnover intention.
So which means direct effect also influencing, indirect effect also influencing. So this is called a partial mediation. Now, sir.
So job, okay, first. Job autonomy is not having any influence on work family conflict time because p value is greater than 0.05.
Okay.
And job autonomy is influencing turnover
Okay,
intention
which
because
means here only direct effect is there. Job autonomy influence turnover intention. So which means there is only direct effect, but there is no indirect effect, which means there is no mediation at all. So first case full mediation, second case partial mediation, third case no mediation at all. Okay, so this is for moderation. Okay, so I think we are exceeding the time. Okay, so now okay, so now for example, the moderator, all these things we can use with the recursion. What is moderator is? Okay, we will draw arrow. We will, for example, okay, so here is arrow. For example, job satisfaction to loyalty. Here we will put some variable that will influence the relationship, that will strengthen the relationship. So it is not coming in the middle, but whereas the relationship between SAT and loyalty is influenced by the relationship is influenced, which means because of the one additional variable, the relationship might increase or relationship might decrease. That means it is a moderator. Okay, it strengthens the relationship. It increases or relationship, decreases the relationship between two variables. That is why we will connect with the arrow, not with the variable. So that we call it as a moderator. So now here in a regression, how we will do is we will multiply in the, for example, here when you put here, okay, when you put here, I will show. See here, it is drawn like this. Independent variable, dependent variable, there is a moderator here. Right? Okay. So now when you here see here, so this variable is a moderator. So now how we will perform? Is the moderator is performed like this. So this variable is taken as independent variable. One, see here, this is a conceptual form, this is a statistical form. When we run, how the result we will get. So now this we know. Now this W, it is having direct influence on Y. Then M into W multiplying with this variable and the moderating variable. Then we will create one more variable for which it will do the effect. Okay. Otherwise, it is called the joint effect, interaction effect. Multiplying with that, adding with that, or multiplying with that. Okay, whether that variable is influences the dependent variable, that we call it as a moderator. Moderator is an interaction effect, multiplying effect. Okay, so one variable into another variable, right? That variable is created and we will run. So in a recursion, we create in the one variable, multiply with another variable, we will create one variable, then we will put that variable as an independent variable like that. Okay, so like that we will run, like that we will run. So here itself we can see, for example, here itself how we have run. See here, so this I want to take as a moderator, right? So now see automatically it is coming. I am not created. So automatically IQ into CI. CI separately, IQ separately, and put together separately. Okay, like that. So whenever we put the model, so like this we will be right. Okay. So all other things we have to write based on the regression only, right? Okay. So now if you have any question, you can ask me. I have to go up to 12 o'clock, right? Okay, very good.
Sure.
Yeah, sir. If they have any question, they can ask, sir.
Yes, sir. Please, participants, if you have any question, please ask to this one. I hope there is no question, sir, from participants. Let us conclude. Sir. Uddipan, please conclude.
So there is no question. Thank you. Thank you very much for 1.5 hour patient listening. I hope you might have understood little bit. I'm trying to explain based on, okay, so logical this one. So how it is coming, all these things I have demonstrated. Okay, so that you will get a thorough understanding. Okay, thank you. Thank you, my dear friends.
Thank you. Thank you very much, sir. Uddipan.
Sir, thank you so much for your valuable lesson. Now that the session is coming to an end, I would like to sincerely thank our resource person, Professor R. Kasilingam, sir, for delivering such an insightful, informative session on structural equation modeling and sharing his valuable expertise and practical knowledge with us. I would also like to thank all the participants for their active engagement and participation throughout the session. Lastly, I extend my sincere gratitude towards the faculty members and research scholars of the Department of Tourism and Hospitality Management, Mizoram University, for their continuous effort and support in conducting this workshop smoothly. So we will have a break now, and the next session will commence at 1:30 p.m. today. Thank you all. See you after the lunch. You may leave the meeting now.
Okay, thank you, sir. Thank you, my dear friends. Thank you.
Your slides. Okay, I'll ask you.